Welcome to this comprehensive guide on database migration to the cloud. In this video, we'll explore the essential strategies and tools you need to successfully move your data from traditional on-premises systems to modern cloud-based platforms. Whether you're just starting your cloud journey or looking to optimize your migration approach, this guide will provide you with the foundational knowledge to make informed decisions about your database migration strategy. Database migration is the process of moving data from on-premises databases to cloud-based platforms. Think of it as relocating your entire data infrastructure from your local servers to the cloud. The key objectives during this process are maintaining data integrity, which means ensuring your data remains accurate and complete, minimizing downtime so your business operations continue smoothly, and ensuring business continuity throughout the transition. It's not just about copying files. It's about carefully transferring your entire database structure, relationships, and configurations to a new environment while keeping everything working perfectly. Organizations migrate to the cloud for several compelling reasons. First, there are reduced infrastructure costs. Instead of maintaining expensive physical servers and hardware, you pay only for what you use in the cloud. Second, scalability on demand allows you to easily increase or decrease your database capacity based on your current needs without purchasing new equipment. Third, enhanced security features provided by cloud platforms often exceed what most organizations can achieve on their own, with advanced encryption, threat detection, and compliance certifications. Finally, global accessibility means your data can be accessed from anywhere in the world, enabling distributed teams and better disaster recovery options. There are three primary migration strategies to consider. The first is lift and shift, which means moving your databases to the cloud exactly as they are, with minimal or no changes. This is the fastest approach, but may not take full advantage of cloud capabilities. The second strategy is replatforming, where you make some optimizations for the cloud environment without completely redesigning your database. This balances speed with cloud benefits. The third is refactoring, which involves redesigning your database specifically for cloud-native architecture. While this takes more time and effort, it allows you to fully leverage cloud features like auto-scaling, distributed storage, and managed services for maximum performance and cost efficiency. Let's discuss the different approaches to executing your migration. Online migration uses continuous replication, allowing your database to stay operational during the migration with minimal downtime. Data changes are synchronized in real time between source and target databases. Offline migration involves transferring the complete database during a scheduled maintenance window when the system is not in use. This ensures data consistency, but requires planned downtime. Hybrid migration combines both methods, allowing a gradual transition where some systems run in parallel. This reduces risk by testing cloud systems while maintaining on-premises backups. Bulk transfer is used for large-scale data export and import operations, typically for massive datasets where you export everything at once and then import it into the cloud database. A successful database migration follows four key phases. First, assessment and planning involves analyzing your current database environment, identifying dependencies, estimating costs, and creating a detailed migration roadmap. Second, schema conversion transforms your database structure to work in the new cloud environment. This includes converting table definitions, stored procedures, triggers, and other database objects to be compatible with your target cloud platform. Third, data transfer is the actual movement of your data from source to target. This can happen in batches or through continuous replication depending on your chosen approach. Finally, testing and validation ensures everything works correctly. You verify data accuracy, test application connectivity, check performance, and confirm that all business processes function properly in the new environment. Several powerful tools are available to help with database migration. Amazon Web Services offers the AWS Database Migration Service, which supports both homogeneous and heterogeneous database migrations with minimal downtime. Microsoft Azure provides the Azure Database Migration Service, designed to seamlessly migrate SQL Server, MySQL, and PostgreSQL databases to Azure. Google Cloud Platform has the Google Cloud Database Migration Service for migrating to Cloud SQL and other Google database services. Oracle Cloud Infrastructure Migration helps move Oracle databases and other workloads to Oracle Cloud. IBM Cloud Migration services support various database types moving to IBM cloud environments. Additionally, third-party tools like Stream provide real-time data integration and migration capabilities across multiple cloud platforms, offering flexibility for complex migration scenarios. Database migration comes with several challenges you need to prepare for. Minimizing downtime during migration is critical because businesses can't afford extended periods where their databases are unavailable. Planning for online migration or scheduling maintenance windows carefully helps address this. Ensuring data security and compliance means protecting sensitive information during transfer and meeting regulatory requirements like GDPR or HIPAA in your new cloud environment. Maintaining data consistency and integrity throughout the migration process requires careful validation to ensure no data is lost, corrupted, or duplicated. Managing large-scale data transfers can be challenging when dealing with terabytes or petabytes of data, requiring robust network bandwidth, efficient transfer methods, and sometimes physical data transfer devices for extremely large datasets. Following best practices significantly increases migration success rates. First, conduct a thorough data assessment before migration. Understand your data volume, complexity, dependencies, and identify what actually needs to be migrated versus what can be archived or deleted. Second, test the migration process in a staging environment that mirrors your production setup. This allows you to identify and fix issues before the actual migration without impacting live systems. Third, create a comprehensive backup and rollback plan. Always have current backups of your source data and a clear procedure for reverting if something goes wrong during migration. Finally, monitor performance and validate data post-migration. Continuously check that your applications perform as expected, data queries return correct results, and all business processes function properly in the cloud environment. Let's recap the key takeaways from this guide. First, choose the right migration strategy based on your specific business needs, timeline, and budget. Whether it's lift and shift for speed, replatforming for balance, or refactoring for maximum cloud benefits, align your strategy with your goals. Second, select appropriate tools for seamless data transfer. Leverage cloud provider native tools or third-party solutions that best fit your database type and migration complexity. Third, plan for challenges and implement best practices. Anticipate potential issues like downtime, security concerns, and data consistency problems, then proactively address them through proper planning and testing. Finally, validate and monitor throughout the migration process. Continuous verification ensures data accuracy, and ongoing monitoring helps you optimize performance and quickly identify any issues in your new cloud environment.
If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.